Hello, everyone, and welcome to your week 2 lecture. Sorry that I can't be with you today. As you're watching this, I will be back live in person next Thursday. So this is a recording, an opportunity for you to kind of learn a little bit, get the content, and then practice as well. We're going to be doing some number stuff. So we'll get started on this. And if you have questions, please feel free to reach out. And I'm going to share my screen here, and then we can get going on what we're doing. All right, so this is week 2. This is one of my favorite topics, which is kind of measurement and numbers. I actually really like doing this part, so it should be pretty fun to do, I think. And I think it's interesting. I'm not sure that you will, but I think it's pretty fun. So let's make this big. See if I can get this to work right. Oh no, that's not what I want to do. All right, we're gonna leave it like this. All right, so week 2, measurement numbers. So one of the reasons we're doing this is I want you to remember and be reminded of what you need to do for using the statistics that you actually learned in a different class. We're not going to do statistics, but we're going to learn and remember kind of what those are and what some of the things were and how they're relevant to what we're doing in this class and the things that we're going to be doing as we move forward. Remember, the statistics is kind of the language we use to be able to communicate about the work that we're doing. So we're going to go over some of those. I'm going to give you some examples. I'll pull in, there's a data file in this week's lecture as well. It looks like this. It's an Excel document that has some stuff in it. And then it also kind of shows you a little bit how to do some of the standard deviations of the problems that we have in there as well. But here's just a sample data set that you can play around with. We'll talk about that in a minute. All right, so numbers. So let's think about it. Remember, why'd you take statistics? What was the purpose? It's probably because it was required. The main reason we take statistics is it's the language that the researchers use to justify the research or why they're making some type of choice in education, why you should use this or why you should use that. And so it's a process of them kind of using these to justify what they're saying and how to convince you to use what they believe is best for you. Okay. And then if you were here, I'd ask you what you remember of it and how do you use it today. So since you're not here, I can't really go from that, but here's a good example of a normal curve. If you remember that all the way back from your statistics days, pretty useful. So there is an example file that we're going to talk through a little bit in here. This is a kind of a typical type of score. Here's each one of these students, and each student has a gender classification, a 1 or a 2. We'll say the 1 is a girl, the 2 is a boy, whatever. Which class they're in, class 1 or class 2. And then also they have their respective reading, spelling, and math scores. The 45 at the top means that's the highest number, that's the total. And this kid got 32 out of 45, 64 out of 80, 43 out of 65. So we'll use that as we go through a little bit to kind of remember how to do some of the things that we've talked about. So if I were to have you, there's a couple ways that you do this. The first thing you could do is you could say, what kind of questions can you ask with these type of data? What kind of questions could you ask, and what kind of questions could you answer with these types of data? You might be able to look at it and say, how did the boys do compared to the girls? Did the boys score higher than the girls? How did class 1 do compared to class 2? How did class 1 girls do to class 2 girls? How did class 1 boys do on their reading compared to how they did on their spelling? Is it good or different? Is there a significant difference in math performance for class 1 as compared to those in math 2? Maybe I did a different approach to teaching math in class 1 than I did in math 2, and I wanted to see if there's a difference in it. Maybe I used a different curriculum. Maybe it's taught at a different time of day. Maybe it's different teachers. Teachers in class 1 are different than the teacher in class 2. So you can do either one. Is there a relationship in their scores? If you did well on reading, did you do pretty well on spelling, and did you do pretty well on math? Is there a relationship between those? We can do correlations along those lines. We might be able to say, how did this individual, say Harpo, how did Harpo do in comparison with his whole class? What did that look like? There's so many things we can do with these types of data, questions we can answer as we go through and process these data. So we're going to look at some of those, and that's how we use measurement and numbers as we're going through and doing stuff with evaluation. Remember, later on, we're going to talk some stuff, we're going to talk about evaluation, and with evaluation, it's this idea that you're going to be able to say, is this approach better than other approaches? Is it worth the money? Is it worth the time? Okay, so keep that in mind. All right, so some of the things, some of the categories that we use, we can do some of the stuff that are descriptive statistics. Descriptives do exactly what we talk about, which they describe. What is the average score in the reading? What are some score ranges and standard deviations for each subject? How many students are there in each class or gender group? Do that. Comparative, do male or female students differ in their average scores on reading? That's a comparative question. We can do mathematical calculations, statistical calculations to get an answer to that. Also do correlational ones. We talked about that as well. Are students who perform well in reading also performing well in spelling and math? That's a correlation. What is the correlation between scores across subjects? And do that too. And we'll look at some of those. But as you have these type of data, there's just so much that you can do with it and questions you can answer mathematically that it makes it very, very useful for us to remember. We didn't simply take statistics just because there was, oh my gosh, why'd this move in the middle there? We didn't take statistics because there was nothing else to take. It was taken because of a very specific purpose, and that's what it is. There's a couple other ones here, distribution-based questions. What percentage of students scored above 80% in each subject? How many scores distributed across different classes? Performance grouping. Who are the top performing students? Who are my lowest ones? Can we figure out who are the lower performing ones so that way they can get better intervention? And then this is what you call composite metrics after standardization. And so basically, what are the overall academic achievement levels when scores are standardized? If you standardize these, put it in a Z-score, how many students scored at, 2 standard deviations above or below, something along those lines. Okay. And the performance index, when you say a composite performance index, that's the same thing as using some of these performance scores that you see on like the SBAC or some of the other areas. They've cooked the scores a little bit to put them into groupings that are kind of false groupings. So many things we can do with this. So when we remember this, there's 4 types of data, and we can go really in depth with this, but I'm going to make sure that you understand. It's very important that we understand this because it determines how we use the data. So there's what we call there's 4 types of data scales. There's more than this, but what we use in here is 4. There's the nominal scale, and data that sit at the nominal scale are categories only. These are things that you simply can identify. So in this case here, the nominal scale would be either a name, or you could also say gender. Gender is kind of a nominal scale. Now we've put it as a 1 and a 2, but that's just for marking it in there. But really, it's male or female. There's no inherent order in any of this. There's nothing else. It's just you put them in a group. Another type of nominal scale would be like if you were to ask all these students what's their favorite football team. There's no inherent order in that. It's just what you group them by. They call that a grouping variable. Gender, ethnicity, IEP status, yes or no, things along those lines. There's no order in the sense of saying that it goes from greatest to least, least to greatest, alphabetical, nothing along those lines. All it simply is it puts you in order. They just put you in a group. So the next scale that data will sit at is a little more complex, and it's called the ordinal scale. So an ordinal scale, basically you have ordered categories. So things can be actually put in some level of order. So a real classic example of that is, say, like fear of crime. So I could say that I'm a little bit afraid of crime, you're kind of afraid of crime, and he's more afraid of crime. We can put ourselves in an order. So not middle and high. We can put that in, there's an order to the way the data appear. And that can be anything. It can be anything. It's not, there's no organization between what kind of and middle is, but there is a level of order. Now there's no level of order for nominal data, no or level of order for your favorite football team, but there is a level of order for something like a Likert scale that basically says strongly agree to strongly disagree. You can put them in order. You can kind of set them up. Okay, class rankings, rubric levels, emerging proficient, you put them in an order. Okay, so this is a way that we organize data. In this particular case, we don't have anything in here that's inherently like that because yes, they're ordered these, but it satisfies it at a higher level. We'll get there in a few minutes. Class 1 and 2, those are just labels, those are groupings. But if we were to kind of put them into proficiency categories, that would be an order per se. Okay. The next one is interval. Interval is not helpful for us in social sciences because it really is what it does is it makes sure that there's an equal interval between each identifying mark. So nominal, no, they're just groups. Ordinal, I say, kind of afraid of crime, somewhat afraid of crime, a lot of afraid of crime. Yes, they're ordered, but the distance between kind of afraid of crime and somewhat afraid of crime, it's not the same as the distance between somewhat afraid of crime and a lot afraid of crime. So there's no equal distance between each one. So interval level data introduces that equality between each one of those elements. Okay, so every single thing, and a classic example of this is temperature. The difference in temperature between 75 and 80 is the same difference in temperature between 95 and 100. One's hotter, but the difference in relative distance is exactly the same, 5 degrees. You can measure that. So that's what it means when you're talking about these interval level data. Now, it's still missing things though. Interval level data, the reason why we only use it in science and not in social science is interval level data is missing something that we call the absolute zero. You still don't have the lack of something, so you can't do all the math with it. Nominal categories, ordinal, you put it in order. Interval means that you've defined the interval between each one. But the best one and the thing we can do the most statistics with and math with are ratio level data. And ratio has all the other things, has a grouping, is in order, has intervals, but it also has this absolute zero. And what that means is when you put zero, for all my math friends in the room, now I can do all math. The discovery of zero was quite an amazing thing. So having that in there, and what you can do is you can do multiplication, things along those lines. So I can go through and I can say, if I look at these data again, Brian was 2 times better than Aaron. You can't do that if it's ordinal level data. You can't do that if it's interval level data because you have no place to be able to do that math with it. So I can do all the statistics that I need. Now, why is this important? It's important because as we're asking a question about something, who did best in the class? Who is my highest achieving or the best achieving students? I want my data to be ratio because then I can do those statistics and math with it. So there's more things I can do with ratio level data. Now, just because I want it to be ratio doesn't mean that it is. If I'm measuring fear of crime, I can't just magically make it ratio. If it is ordinal level data, that's just what it is. If it's only categorical data that you're going to be using, which is that nominal stuff that you're putting categories on, that's all it is. You can't change it. But you can do certain statistics with different things. So just be aware as you're looking at it. So let's take a look at some statistics that we actually use. So by and large, we're going to be looking at kind of these, we're going to be looking at the ratio level data to kind of look at all these kinds of data that we're looking at, okay? So the first thing are frequency distributions. A really good frequency distribution, a classic one is this one here. It's the normal distribution. So frequency distribution. You usually can use pivot tables in Excel or Google Sheets. I've never used Google Sheets for pivot tables, but I have used Excel quite a bit. And there's lots of ways that you can use it to be able to build your data in certain ways. So if you want to be able to put your reading scores in there and then kind of put your classes in, you can see how they've done it. And this one here is a sum. We can change that to, let me see here if I want to do this. Come on. It's not giving it to me here. All right, there we go. If I don't want sum, I don't want it to add it up. I would rather have the count. So if I do a count, it gives me how many people are in each area. There's 26 in each one of the classes. And then and we have a count of that. But then if I want to, I can kind of put spelling in here to be able to see the frequency count of each one of these. And that gives us a little bit of a distribution that we actually have. So you could actually go into pivot charts and it will make either distributions like that. You can design some of them. You can actually make certain types of charts that you want to be able to use You have chart elements that you can use. You can use bar charts. You can use some of these frequency things along those lines. And it's pretty easy to use. I'm not asking you to do that, but I'm just showing you how you can do that. So your data is in there. Pivot tables will do that. And a frequency distribution kind of gives us the number of students at each one of the performance levels. It tells me who's doing what. Now, in this particular case, when I'm looking at these data are not, I'd have to group them together to be able to do it. If I wanted to go in and do something different than that, let's take a look here. Let's pull this out and let's put gender into here. And so now when I go and do this, you can see, where's my pivot tables? Oh, it doesn't like what I'm doing. But anyway, we're just gonna play around. But this is a way for you to be able to see it. So you can see there are 15 people who are a 1 here and a 1 there. So the column is gender. So that was girls who are in class 1, 11 boys who are in class 1, total of 52. It's just a really quick way for you to manipulate and use data. Pivot tables are useful. We get cumulative percentages with frequency distributions. We'll also get some bar charts. I'm going to show you. Here's a couple of them. Here's a couple of frequency distributions that are pretty useful. Here's a bar chart that allows us to kind of get categorical data. You get a frequency count along those lines. Here's a line graph that you can actually do, fairly similar. Again, it's getting frequency. Frequency is measuring the frequency or the number of people that meet a specific condition. Here's another one, bar graph grouped. This actually is a type of histogram per se. Again, it's just giving me the frequency. The bigger the bar, the greater the number. It's great, really easy descriptive tool to be able to say what's the number of students that meet a certain category. Frequency distributions are a good way to start. This is a special type of frequency distribution in the normal distribution that you have here, because that actually is something that's a little more predictive. If you remember that from statistics. So you have this 50% right in the middle here, and with a normal distribution, the way that they break off on each side, it matches up exactly each way. Therefore, you have the mean, median, and mode are all the same right in the middle. It's your old normal distribution that you use for z-scores, just as a reminder. So another way to measure some of these are central tendency, which you guys remember. If we were here, we'd talk a little more about it. Mode is the most commonly occurring number in the area there. The median is the middle student, the exact middle. Percentile is the students that are in a specific percentage of scores are below them or at the top of a certain percentage. 75th percentile is basically they outperform 75% of their peers, whatever that may be. And then the mean is the average. So sometimes we get these a little bit kind of mixed up. You learn these in 4th grade. The mean is very, very sensitive to outliers. We have to be careful of that. What that means is that if I compare your salary to Bill Gates is so much further, it's going to pull the average salaries up. Whereas the median gives me the exact middle and is not as influenced by outliers, if you remember that. Very useful tools for us to be able to describe something about the way the data are clumping together, how they come together. Very, very useful. So you can get means by using the data analysis pack that's on here. And let's see here. So there's certain ways you can be able to do it here. There's also, if you go into here, and I'm not going to remember how to do it. If I don't remember, let's see here. So if you go into tools and you go to Excel add-ins and you do the analysis tool pack, which is right there, you should be able to see. I'm going to move this out of the way. The formulas should be in there. I can't remember where you put it, where it throws it. Formulas, data, got it. And you should have your queries. There's your analysis tools right here, data analysis and analysis tools that you have if you want to be able to use it. And when you do the data analysis, you can kind of pick out any one of these types of data. You can do histograms, you can do correlations, you can do nodes, you can do descriptive statistics. So if I do descriptive statistics and I choose, let's just go through here, that in there. See what it gives us. Labels on the first row, do a column. Let's choose the output range to be up here. And let's get summary statistics. Let's do the largest and the smallest. Let's see what we get. Okay, so what that's done for us is very quickly, it's given us kind of values that it gives me the mean, the standard error, the median, the mode, the standard deviation. I mean, look at this very quickly of this. These are the reading ones. 45 gives me that. What's the maximum score? What's the minimum score? It's the sum that doesn't make any difference for us. How many people took this test? What was the largest? What was the smallest? Obviously, it's the same one here. But it gives me skewness, kurtosis, which are measures. Very quick way to be able to do it. Why is this important? What's the average score in this test? Yeah, what was the exact middle? 34 was the mean. 35 is about the median. It's the middle score, and the most frequently occurring is like a 36, which makes sense. Had a 5-point standard deviation, which we'll talk about in a few minutes. Very quick way to be able to use Excel to go through and analyze your data. Again, so the way I did it was I went into tools, I added in Excel add-ins, and I added the analysis tool pack, and then I go into data analysis, which is right here, and I picked descriptive statistics. Now this is in Mac, it's going to be a little different in your PC, but it's fairly similar. Okay. So lots of ways to be able to do that. So if you were here, I'd ask you more questions, but you're not. Variability is another thing that's important for us to be able to know a little bit about. When we look at the measures of central tendency, it's getting a little bit at how things are grouping together. How are they actually coming together? Variability gets at how are things spreading out? What's the distribution? How are they kind of doing something a little bit different? So there's several measures of this. There's the range, there's the interquartile range, which will show you that in a few minutes. Standard deviation, which is the most important. We use that all the time, and then we'll talk about it. And then box and whiskers plot. Standard deviation is simply the average distance from the mean, if you remember that back in the days. And it's important for us because it tells us how the data kind of spread out as we're going along. So let's look at a couple of these. The first one's here's a box and whisker plot that uses several data points to put this together. The box is here, the whiskers on either side. So if you look at a data set, you can put it into this box and whisker. The first thing you do is you'll calculate the median. So if we were to look in here, here's our median right here, 35. That's the median. That's the middle of the thing here. The next one are these two quartiles that you have. What's the score in the upper quartile? Meaning that there's 25% of scores that fall between the median, exact middle, and this upper quartile here, which is quartile 3. So if you look in here, sometimes they'll give this to you. You can calculate it. There's other ways to do it, but it's just telling you what is the score that actually falls at that quartile there. What's the score that 25% of scores fall below the median? You notice they're different. They don't have to be the same. It's where real data fall. These are a little more compressed down below. This one here spread out a little bit. Then the other one is the minimum score, the lowest score. The top of it is the maximum score. It's a kind of a 5-number description. So you got the maximum, upper quartile. What's the score at the 75th percentile? It's the 50th percentile, 25th percentile, and what's the minimum or low score? That's what that means. And this tells me how spread apart this is. This is the interquartile range. This is the score at which 50% of scores fall between. Okay, they are kind of in the middle of those. Very useful way to describe the distribution of the way these things are spread apart. Okay. If this box is really small and it's kind of, that means the scores are all very close to each other and alike. If it's really spread apart, that means they've kind of spread across the distribution. Think of this as times on the track when you're running. As you go through this, the faster runners will probably be down here, and my slower runners will be out here. The closer together they are on the track, like if they're running very similar to each other, that box is going to be really small. But if they're spread out, you have some really fast guys and some really slow guys, they'll be spread out and that distribution is broader. And that tells me I've got some work to do. You can do the same thing with test scores. If everybody's scoring very similar, then everybody's doing pretty much the same. And we can see that. But if you have a distribution to be able to say that these guys, you have some people who are really scoring high, and then you have some people that are scoring really low, then you've got a real broad range of performance in that class, which might be a concern. All right. Standard deviation. Standard deviation is the average distance from the mean. It's telling me again, gives me a little bit of information about how the scores are spread apart. A large standard deviation means that the scores are very spread apart, very broad across the range. Small standard deviation means they're very clumped together, which tells me again where they actually fall in that distribution and how much work I may have to do to be able to fix it. If they're all close together, then everybody's kind of clicking on the same things, doing fairly well. So here's a question that comes out of a sixth grade exam. You're a coach on a bowling team. You can only make one more player with you. Take one or more player with you to the match. You have Billy and Sally to choose from. Here are the scores. It's to the right, not to the left. Who do you take and why? So here's Sally's bowling scores. Here's Billy's scores. You have to ask, who are you going to take? They have exactly the same mean, pretty close. Sally scores a little bit better, but not much, but they have a wildly different standard deviation. So their mean is pretty much the same, but standard deviation. Remember what we talked about, grouping of scores together. Sally seems to be pretty darn consistent. She has very consistent scoring type, and therefore you can pretty much guarantee that Sally's going to score somewhere in that range, as opposed to Billy. Billy's got some fantastic potential. He could be scoring up here in the 215s, but he also has the chance of just blowing it out majorly with a 130. So if you're looking for someone with greater consistency, then you're going to want Sally. But if you've got someone who's going to be so much better on that team, on the other team, that's going to be scoring in the 200s. Well, there's no way Sally's scoring in the 200s. Billy, though, could. Billy might. So you may take Billy. It depends, but this gives us this idea of variability. It gives us a little idea of how they actually score, how their scores range across this. Okay. So you can see where we got the standard deviation in there. Standard error, standard deviation, and all those. All right. Again, were you here, I'd be asking you lots of questions, but we're not. Another measure is something called the z-scores, which you learn in statistics, and z-scores are simply their standard deviation units. You take a standard deviation and you say what score falls, one standard deviation, two standard deviations, 2.3, and all of the z-scores are simply measures of the standard deviation. And what it does is it takes a raw score and it turns it into something we can compare. If I have someone who scores a raw score of 10 and another one scores on a completely different test a raw score of 30, it's hard to compare them. But if I know that the first score, that 10 puts them at a negative 0.3 standard deviation or z-score, and on the other one they have a positive 0.1, they did better on the other test because in comparison to that, they've changed it into a standard deviation, and you can actually compare the two together. They're different raw scores that you're looking at. Very useful in statistics, very useful in education. That's the actual function that you can use to be able to do it. Just remember, it is a very useful tool. This is how we actually use that when we talk about the percentage of scores that fall. So we know that 68% of scores in a normal distribution fall within one standard deviation from the mean. Now, I said that fast, but what that means is if I were to say the average height of a man is 5'8", then we say to you that one standard deviation away is 2.5 inches. Then we know that 68% of men, white men, are between 5'10 and a half and 5'6", 5 and a half. That tells us that gives us that information. So if you meet someone who's outside of that, you're starting to see someone who's moving a little bit higher, going outside what would be normally distributed. Okay. So it's a way for us to kind of look at these scores and put them reshape them so that way we can be able to do some comparisons. It's how we use all of our statistics to talk about z-scores. It's how we actually do comparisons to say who's in a 50th percentile, who's in the 80th percentile, because they'd be up in here and all the other scores would be down below. But z-scores, if you remember them all the way back. All right, let's talk about our last one, which this is really correlation, scatter plots, and regression, if you remember that. Correlation is a very easy one to remember. As you look at a correlation, you're actually looking at a distribution of scores and how they actually fall across two areas there. So here's a nice idea of a correlation or a scatter plot that you have. Per capita income in the thousands percent with a bachelor's degree. So what you see is each dot represents a comparison. So this is how much this person makes, and the percent of the people with a bachelor's degree in a particular area, the per capita income, so how much people make. These are cities across the world, around the world. And you can see that the more people in a city that actually have a bachelor's degree, the per capita income goes up. This is a correlation that's positive. It's moving in this direction. And this is a way for us to visualize data. It's a way for us to visualize a comparison between two elements. And that's all this is. It's a scatter plot that we use, very, very useful. We also use correlation coefficients that range between -1 and 1. And actually, it's 1 and -1, but whatever. And if you remember that, basically a strong correlation simply means that they're related. It does not mean that it causes one another, but that there is a relationship between one and the other. Bachelor's degrees don't cause income to go up. Income doesn't cause people to go get bachelor's degrees, but there's some level of relationship. It's not, we don't have a causal factor. We're just looking at correlations along those lines. Okay, and so you can, again, there's lots of ways you can be able to do data sets in here. You can use different types of charts. A really good chart to be able to use is this scatter plot. You can actually pull data in to be able to use this. This is not a good one because it was pulling out that data that you have there. But if you were to pull these in, you can be able to actually compare two data sets like here. Let's take a look here. And we'll insert this, pull this down. Here's a nice little correlation that you have. There's a correlation between their spelling test and their reading test. So spelling's up here, reading's up here. So people who scored this, people here got an 8, got 21 on a spelling and a 44, or 21 on the reading and a 44 on the spelling. And you can see that's where they go. And if you wanted to do this, you can kind of get a special line. We're going to add a trend line. I just right-clicked on any of the dots, added a trend line. And what that does for us is that it's a linear trend line that we actually have there. And what that does is that gives us the exact middle of those data sets. And that, my friends, is what we call regression. So regression simply is a predicted value. It says if you got 1, what's it predicted that you're going to get for the other one? So regression is a way for us to be able to predict. Again, these are all just refreshers from what you did in statistics. I want you to take some time and play with the data set, play with these values, go in, try to remember how to use it, because as you're starting to ask questions about how you're going to measure your evaluations or the other work, this is what's going to help. Happy to answer questions. I hope you're all well, and we will talk next week.